the metric system. What is it? How does it work? To get the metric system, we need to understand first, like why do we use it at all? Okay, we use it because it is an incredibly easy system to convert. To prove that point, take a look at this. Okay, now who takes into account or remembers that there are 63,360 inches per mile? Probably not very many people, but it's a little easier to remember that there are 100,000 centimeters in a kilometer if you had to for some reason. But it's also easy to convert because we're always just working with powers of 10. So metric system, what is it? Well, metric system is all of the units that we see here in this word cloud in blue. The units that are in gray are the imperial or the English system. A second reason why we use the metric system in science is it is the international system. So scientists all over the world use the metric system. Thus, we are going to use it in our classroom when we are doing science. So those are the two biggest reasons. Measurements. There are 5 different measurements that we are going to use in this class, and maybe a few others, but these are the main ones. The first one is weight. Next is volume, mass, density, and length. So what are these? Well, weight is a measurement of the force of gravity on an object. So, I mean, this is going to change depending on what planet or wherever you are in the universe. The weight on the moon is going to be different than the weight on Earth. And so weight is the measurement of that force on an object. The measurement of the force pulling objects to the center of the planet. Okay? Volume is measuring the amount of space that an object takes up. When you think about this, think about, when you jump into a pool. Wherever you are in that pool, water is not, and so you are taking up space in that pool. So that's volume. Mass is the measure of an amount of matter. What is matter? Matter is what everything is made of. Solids, liquids, gases are all made of matter. Anything that's not matter is energy. So matter is everything. Mass measures matter. Now, mass would not change depending on what planet you are on, because you can never really change the amount of stuff or the amount of particles that are inside of you. Okay? So that is mass. For density, density is combining 2 units of measurement. Density is an amount of matter, so that's mass, in a space, which is volume. Okay, so it is a mass in a volume. Density is how closely together that matter is packed. So matter that is tightly packed has a high density. Matter that is loosely packed has a lower density. Length, the distance between 2 points. Now, we had a discussion in class, the difference between distance and length. Really, I mean, and in some cases they're kind of interchangeable, and it's hard to kind of differentiate how length and distance are different. But always a good discussion. Next, the measurement units with each one. Okay, so this is a continuation of the diagram. Weight, the measurement unit will be newtons or pounds. Volume, the measurement unit in metric, is liters. You may have seen a 2-liter bottle of soda. Hopefully you didn't drink it all by yourself, but you've seen them. Okay, grams, you may have seen grams on packages of food or Yeah, mostly that's where we see them. Okay, grams is the unit for mass that we will use. Density, remember, it's combining two types of measurement. It is mass over volume. Oftentimes in class it will be grams over milliliters, or it will be grams over cubic centimeters. A cubic centimeter is the same amount of space as a milliliter. The unit for length that we will use is predominantly meters, or sometimes centimeters, and even sometimes millimeters. Okay, but meters is kind of the base unit. Okay. Next, what do we got? We got metric conversion. Okay, easier than you think. Conversion, big word, but conversion not hard. Okay, 1 meter, if you've seen a meter stick, is 100 centimeters. We should know that. We should be able to, get to that quickly. 1 meter is 100 centimeters. So if there's 10 millimeters in 1 centimeter, how many millimeters are in a meter? That could be a tongue twister. Try and say that 10 times fast. Never mind, don't do that. Okay, well, 1,000 millimeters is going to equal 1 meter. Okay? So, quick math. If you have 2 meters, how many centimeters would that be? Hopefully you said 200. Same kind of math. If you have 2 meters, how many millimeters would that be? You guessed it, 2,000. Okay? So, an easier way. That was kind of the math way. There's some different things you can do with fractions, but most often in science class, in 8th grade, we're going to use the step chart. Okay, so the base unit, this can be grams, this could be meters, this could be liters. It's just whatever you are measuring. If you're measuring mass, then grams, volume, then liters. If you're measuring length, then meters. So it really depends on what you're measuring. But let's say you start out 5 grams. So grams is going to be right here. And you want to go to centigrams. Centigrams is over here. So that is 1, 2 steps to the right. Am I right? Yes, I'm right. So we need to move the decimal point 1, 2 places to the right. So let's do that. Here we go. 1, 2, and we're done. What do you mean we're done? I mean that's the answer. That's how easy it is. Okay? We can do that. The other one, 2.7 millimeters, 2 kilometers. Whoa, that's a lot of steps. It's okay. So millimeters is here, kilograms or kilometers way up here. So 1, 2, 3, 4, 5, 6 places. What direction are we going? We're going to the left. So here we go. 1, 2, 3, 4, 5, 6, and we're done. Yes, that's how easy it is. Okay? Try some practice for yourself. Pause the video. Try 8 kilograms is equal to how many grams? Then try 3 decimeters is equal to how many millimeters? Then try 4.2 liters is equal to how many hectoliters? If you have questions about these problems, come see me in the morning and we'll help you out. Alright, that is it for our notes for Goal 1 in the Foundations unit.